Hello, everyone. Happy Monday. It feels like it's been a while since I got to talk to you. But a couple things. Let's chat about the tests. I do have all of the scores in Schoology at this point, so you can go ahead and check your score. If you submitted it through Schoology, like when you do the quizzes, I actually put some comments on there. So read through the comments. I tried to write to you what you did wrong or which ones were wrong. So you can see that on there. If you sent me an email, I didn't reply back to you with all the different ones that you missed. If you want to know which ones you missed, feel free to email me. I could always email you because I do have it all written down. So, but they were very good. They're what I expected. Everybody was fairly timely with them. We will do the exact same thing for exam 2. Okay, so now you are aware of how that process works. We will be doing the exact same thing for exam 2. So exam 1 was out of 65 points. And as far as most missed questions, I don't know if I can pinpoint a most missed. There was just little things here and there that you guys missed. So a lot of -1s. Rather than like a -5. So I was happy about that. But other than that, they were very good. So keep that exam 1 somewhere handy because you will see some of that information again on the final exam. So it's worth going over and looking at it and making sure that you know how to do all of those problems on exam 1. Also, keep up with your quizzes. So today, quiz number 4 is actually due. Okay, so a lot of you already uploaded it, but that is also due today. So please make sure that quiz is done for today. Hopefully you saw some of the quiz questions on the exam because the quizzes will help you score well on the exam or know at least how to do some of the problems very quickly. So other than that, I don't have much to say about that. Everything was pretty good there. So moving on right along. Today is technically class number 6, I believe. Hopefully I have that right. Even though we had the test, I called it number 5. But as far as chapters, today we are looking at chapter 3. And specifically, it's chapter 3, 1, 2, 3, 3. So there will be 2 days, 2 Mondays of lecture here for chapter 3 because we have the end part coming next class. Okay, so starting off with chapter 3, 1. 3.1 deals with, which is primarily in the name of this course, in fact, the entire chapter 3 deals with functions. Okay, so getting a little bit more mathematical in math, we start switching over. Instead of calling things equations, we call them functions. And it is a different notation. So let's start out with a couple definitions here. So first, that's going to be a relation. And a relation is any set of points. Okay, and I'm going to kind of stop there before I get into the actual function part of it. But a relation is any set of points. So there are actually many ways I could present points to you. And I want to go through a bunch of those right now. Okay, so letter A, I could just list them. So for example, -1, 2, 3, 4, and maybe 2, 0. Okay, so voila, that's a relation. That is some points. Okay, I could give them to you in a table. And so I don't really have to call it an XY table, but that's why it is called an XY table, because there are points. So keep in mind our points are X and Y. So I could put these in a table. I could do 2, 1. I'm just going to give you a couple different examples here, guys. 3, 4, and I could do 2, 0. Okay? C, I could put these things on a graph. And more specifically on a graph, I could actually put the points on the graph. So let's look at that. And I could put some points on here, say 3 comma 2. I could put on here 1 comma 1. And I could put on here 2 comma, say, negative 1. Nice. So, and I could just put the points physically just on the graph for you. I also could give it to you in words, which is very rare. Typically, they don't give them to you in words. So I'm going to go ahead and let that one go ahead and go today. But as far as a graph, I could also give it to you as a picture. So, and of course, there are points on this picture, but I could give it to you as, say, picture. Okay? So something to that effect. Lastly, part E, I could give it to you as an equation. I like to save E for equation. Okay, and that would be something to the effect of like y equals x plus 3, y equals x squared minus 4, or like x squared plus y squared equals 16. Okay, so there's a couple ways I could present the points to you, and those are all the different ways you are going to see. Okay, now, as far as I'm concerned right now, these are just points. These are just relations. We have not determined whether or not they are a function. All right, so that's a different story. So when you talk about things being functions, all right, there is a mathematical definition. So I am going to go ahead and give you that mathematical definition. If to each independent variable x, there corresponds exactly one value of the dependent variable. Oh, geez. Spelled dependent wrong. Every time I'm trying to write, I always tend to spell things. I'm thinking of the next word. The dependent variable y, then it defines a function. Okay, now I always thought, I remember being in calculus 1, 2, 3, 4, 5. I always remember that definition was so long and we always had to use it. And so bottom line, what does it mean? Okay, so basically it means in a function, the x cannot repeat. Okay? That when you start talking about function, you start talking about real life, you start talking about things that can happen, the x cannot repeat. And that's what we need to be looking for. If it repeats, then it's not a function. Okay? So if the x repeats for different values of y, then it is not a function. Okay, so that's the key. Now, if you ever wondered why is that? If I take the example 2x plus 1, and if I try to let x equal 3, I'm going to get, for a while there, we're going to get y equals 7. 5 days later, if I come over and I put x equals 3 again, I'm not going to get a 10 this time. That's never going to happen. You cannot have two x values with that are the same with two different y values. Okay, so basically, if x in real life turns to time, in 3 seconds, I can't be at 7 feet and 10 feet at the same time. You cannot be in two places at the same time. Okay, so that's the idea. The x cannot repeat. So let's go back and I want to look at each of these individually, and I want to see if they are functions. Okay, so let's look at the list first. So is this list a function? Well, we look at our x's, and they are all different, so therefore it does constitute a function. So that one is, in fact, a function. Okay, if I look at my table, and I look over here, I see that, oh, wait a minute, my 2 repeats. More specifically, it's 2, 1, and 2, 0. I can't have different y values with the x repeating. So this one over here is not a function. Okay? Graphing with points. Regardless if I put them on a list, on a table, or a graph, there are still x values. You have 1, 3, and 2. Those are all different, so this is in fact a function. Okay, now, that's all well and good when you have numbers. We have to use something different when we have a graph. And when you have a graph, this is why you learn something called the vertical line test, and this should be familiar to you. Okay, it's basically a test to test and see if things are functions. So what you do is you draw a vertical line, and you envision that vertical line moving, so I can move it here, along my blue graph, and anywhere in that graph does it touch twice, it would not be a function. But this line's good. Okay, so it only touches that graph once everywhere, so this graph is in fact a function. Okay, some other ones, just to kind of give you another one over here, a little side note. So if I saw a graph and it would be somewhat of a sideways U like that. Okay, this one, so take my vertical line, I'll borrow it. If I take this one would not be a function. Okay, so because right there it would touch twice, so that one would fail. Okay, so just FYI on that, that is the vertical line test. We will be talking about that, but I think you already know that, so I don't really want to teach it anymore, really. But that vertical line test is a test to determine if a picture is a function. Okay, and then the last one is the equation. How do you determine if an equation is a function? Because you really don't have any points here. So how do I determine that an equation is a function? And truly all you need to look for is a y squared. So if there is a y squared guys, not x, then it's not a function. Okay, the y squared actually turns functions sideways. Okay, so this one is good, this one is good, however the last one is not a function. And in fact, this is a picture of a circle. Okay, so if you envision a circle in a graph, that's the equation of a circle, that would 100% fail the vertical line test because it would touch twice. Okay, so, and that's just like an x repeating because the vertical line is x. So as far as that, all you really need to look for is that y squared. If you see a y squared, it is not a function. That's the easiest way to determine if an equation is actually a function. Okay, so something else that happens once you determine that it is a function. Okay, so if it is a function, then we can talk about domain and range. Okay, and two familiar words, you probably heard of those before. All right, so domain is a list of the x values, list of possible x values. Okay, and I always say that work, if you look at the definition, they're x values that will produce a real answer for y. Okay, so they're a list of possible x values. Range is a list of possible y values. Oops. Okay, Now, it is possible to find domain and range. Okay, so if I go back to my examples here, I can actually find the domain and the range. Okay, so as far as domain, when you have a list, the domain is just literally a list of the x values here. So -1, 3, and 0. -1, 3, and, oh, sorry, -1, 3, and 2. Typically, they're written in order. A lot of times there's different notations here. I typically use the brackets, just -1, 3, and 2. There's nothing else I see there. You can't say, oh, -1 to 2 or -1 to 3. No, because I don't see an x value of 0 up there. Okay? So be careful when you're doing that. Those are specific x values. The range is the y value, so you literally just have to look at the y here. And I'll go ahead and put it in order. You have 0, 2, and 4. So again, those are your possible y values. Okay? Because this one is not a function, we really don't do the domain and range on that. Okay? We really don't speak of that because it's not really important. Okay. Next one, C. If I have specific points, I can identify domain and range. So as far as C, my domain is going to be 1, 2, and 3. Okay? My range is going to be -1, 1, and 2. And again, specific x values. Okay, now, it gets a little bit more complicated when you have to do domain and range from a graph or an equation. And that is what we're going to build. Okay, domain range looks a little bit different. You can only do the simple listing of the domain and range if you're given physical points. Okay, all right, so with that said, we're going to kind of jump to a little bit more in-depth look at domain. Okay, so, and primarily with functions, so domain. All right. In my opinion, there's 3 types of domains that you'll need to worry about. So I am going to list 3 rows of things here, I guess. So let's list them down this way. So 3 functions, and we'll go ahead and do, whoa. Sorry, don't want that graph yet. Okay, so domain. I'm going to go ahead and list x squared, 3x plus 4, and x cubed plus 2x plus 1. In the next row, I'm going to list 1 over, and these are all y equals, I guess I should be technical here and put y equals 1 over x plus 4, and y equals 1 over 2x minus 1. And the last column, square root of x minus 3, y equals the square root of x plus 5, and y equals the square root of 3x plus 1. Okay. And this is more specifically domain of actual equations. And it does hold true, guys, that these are all functions as well. Okay. So they are functions. And we'll talk about, and the reason they are, well, I guess take a look. Do you see any y squareds? No. Okay, so they're all functions. All right, so let's go. What do you notice? Well, first off, hopefully you noticed about the red ones. What do you notice about all the red ones? The red ones are all fractions. Okay, they have an x on the bottom. They have a 1 up top. How about the blue column? But the blue column has all square roots. Okay, so I got some square roots there. The column that's written in the black pen, though, is there anything that you see here out of the ordinary? Does it look like just a nice, normal polynomial equation? Okay, and as a matter of fact, it is. So we're going to really start looking at functions here. We're getting into actually the name of this course, and it makes me happy. The second one here is a linear equation, just a regular y equals mx plus b. Okay, the top one is quadratic, so that's your typical parabola. And the last one is a cubic function, so it's x to the third, and that's okay too. There's no fractions in here. There's no square roots. There's no negatives. It is a nice polynomial equation. Okay? When you have a nice polynomial equation, the domain is always all real numbers. And I've seen that written 3 different ways, believe it or not. I've seen it written all real numbers, and I've actually seen kids do that. I've seen kids write negative infinity to infinity. That's every number in the world. And I've actually seen the symbol, that double-lined R, means all real numbers. So I don't know what you did in high school. I don't care what you do. Somehow you have to identify, or you have to tell me that it's all real numbers. So for every one of these, the domain is all real numbers. What that means is I can put any x in the world into that equation and get an answer. Anything. Negative 5,000. Yep, I could throw it in there and get an answer for y. There is no restrictions on x. I can use any x that I want and get an answer for that. All right, now the red column. The red column has a little trick here. You could almost use every number in the world except one number. Okay? When you have a fraction, the bottom cannot equal 0. So for fractional equations, when you're doing domain, the bottom cannot equal 0 under no circumstance. So what I like to do is actually do a little equation here. Take this bottom and just write it cannot equal 0. Add 3 to both sides. You get x cannot equal 3. We have just found the one number that x can't be, and that's 3. Okay? So a couple ways to write that. I've seen people write all real numbers except x cannot equal 3. If you just state to me the number that it can't be, that's okay too. You could also do interval notation for that. If you learned that in high school, you would write negative infinity up until 3 and then 3 to infinity. Okay, so next, the bottom cannot equal 0. So if I work backwards, x cannot equal negative 4 under no circumstance. So that is going to be my domain. Okay, with the bottom one, I'm a little bit more tricky here with the bottom one, just because I have a little equation here, but this bottom cannot equal 0. So if I work backwards, divide by 2, I get x cannot, I always forget my cannot sign, my x cannot equal 1 under no circumstance. The bottom is not allowed to be 0. So the domain is understood that it can be any number in the world except 1/2. Okay? So all the ones with fractions will have one number that will not work, and you need to find that number. All right, and then the last column is the square roots. So what do I do for square roots? Well, something's not allowed to be under square roots. Okay? And what is that number that's not going to give me a real answer? And that's negatives. And I know you guys have seen that. The last one, I put it on your quiz and I put it on the test, I believe. The very last question had a square root of -9, I believe. And that made 3i and -3i. So those are not real numbers. So basically for square roots, I always tell myself the inside has to be greater than or equal to 0. The inside of a root, it can be 0 because the square root of 0 is 0. And it can be anything greater than 0, okay? But it cannot be negative, okay? So hence the reason I put the greater than or equal to 0 there. So basically what I do is literally just that. I take the inside and I set it greater than or equal to 0. And you solve an inequality. So focus over here, working backwards, I'm adding 3 to both sides. X has to be greater than or equal to 3. So your domain, x has to be greater than or equal to 3. And that means there's a bunch of numbers that work there. 3 works, 4 works, 5 works, 6 works, but anything less than 3 will not work, okay, because you'll get a negative underneath that square root. So your domain here is x can be anything greater than or equal to 3. And of course, guys, you do know interval notation for that. So technically, you could do a graph for that, and you could write that 3 to infinity. Okay, anything from 3 to infinity would work. So if you want to give me interval notation, go for it. I don't really teach it that way. I know some teachers do. Either way. So either one will work. So there's the domain. Next one, this inside cannot be greater than or equal to 0. So if I subtract 5 from both sides, x has to be greater than or equal to negative 5. So that is going to be my domain. Okay, x has to be greater than negative 5 or equal to for that to work. And the last one, again, a little bit harder, just because I have the equation here a little bit. So 3x is greater than or equal to negative 1. If I divide by 3, beauty of a smartboard, I can just move my notes. I have x is greater than or equal to negative 1/3. So my domain has to be bigger than negative 1/3. Now, my opinion, domain is one of these 3. I don't care if you go up to Calc 10. Domain is going to be one of these 3 for every function of mathematics. Okay? If you see nice polynomial, it's going to be all real numbers, period. If you see fractions, okay, so whatever, if there's a fraction in your function, we have to know that that bottom cannot equal 0. Okay? And furthermore, if you see a square root somewhere in your function, you need to know that that inside of that square root has to be greater than or equal to 0. Okay? And then you find in the blue section with the square roots, you find a range that it doesn't equal. You find actually a couple numbers that x works for. The red part, if there's a fraction, you've got to find that one number that it does not work. And of course, you need to know if it's all numbers that work. Okay? So I like to go back to domain and almost like to kind of think about that. It's a list of possible x values, and I actually do kind of write that down. It's the x's that work, or that makes sense, or that give me an answer. Okay? And that's kind of the idea. Your book does focus on domain, so we will be doing a lot of domain. Not too much range. I don't really get too much into that, but we will be doing a lot of domain. Okay? All right, so with that said, I'm going to go ahead and stop here because I do want to talk about function notation, and then I want to go into domain a little bit more with that. Okay, so there's going to be 3 videos this week for sure, just because I like to section them off at these topics. Okay, so that was the video. That is a little short video for the part 1, but tune in for part 2.